Hello dear students, welcome back. Today we are going to discuss about the last topic of our chapter, that is uniform circular motion. You are familiar with the word uniform motion or uniform speed, isn't it? Uniform motion or uniform speed is said to be possessed by a body if it covers equal distance in equal interval of time. Equal distance in equal interval of time. So we are adding a term circular. If the body is moving in a circular path and if it covers equal distance in equal interval of time, the body is said to be in uniform circular motion. If the body is moving in a circular path and if it covers equal distance in equal interval of time, the body is said to be in uniform circular motion. That's all about circular motion. Just add the body if the body moves in a circular path. If you are adding this term to the definition of uniform motion, we can get the definition for uniform circular motion. So that is uniform circular motion. So if a body is moving in only circular path, no, it's not perfect. Anyway, if a body is moving only in circular path, it is said to be in and it have to cover equal distance in equal interval of time. If it does so, it is said to be in uniform circular motion. Now let's come to the case of circular motion. A body naturally does not wish to go in a circular motion, isn't it? If you are walking or if you throw a stone, does it go in circular motion? No. A body normally doesn't like to go in a circular motion. It do like to follow a straight motion. But if we are giving some external force only, the body is moving in circular motion. See, I have an example here. So a stone or a chalk that is tied into a thread. You can do it with a stone also. So what happens when we rotate this? The body is moving in circular motion, isn't it? When we rotate this, the body is moving in circular motion. So we are giving an external force using a thread, isn't it? And this body is always pulled to the center of the circle. It forms a circle here and the body is always pulled to the center of the circle, as like in the case of gravitational force. Sun pulls the planets around its motion in an orbit, or it makes the planets to revolve around in an orbit as like this. If the center portion is the sun and this are planets. So planets are moving in a definite order only because of the pull of the gravitational pull of the sun. As like in every circular motion, this is the case. So we need an external force. In the solar system, the external force is provided by the sun. Here we are providing the external force with the help of a thread and our hand. So if we are giving an external force, this force is always pointed towards the center. And see, this type of force which is always pointed towards the center is called centripetal force. Centripetal force, that is center seeking or loving force. Center seeking or center loving force is called centripetal force. The opposite of that is centrifugal force, that you will study in 11th, that is +1 or +2, you will be studying centrifugal force. Now it is centripetal force, that is central loving force or central seeking force. So in case of a circular motion, the body is moving only in circular motion because of the force we are giving to attract them to the center of the motion. So in this case, see, if the body is moving, so if it reaches here, it does need to go this way, isn't it? If it reaches here, it does want to go this way, but what happens? The pull from the center make it down. When it is coming from here, it really needs to go that way, like this. But what happens? The center of the circle does pull it downwards, so it moves like this. So at every point it does want to go like this straight, but pull from the center make it in a circular motion. So that thing is drawn here. So at every point the stone or the body does want to go in a straight line. These lines are called tangent. So you will study in your maths, maybe in 10th standard or sometimes in 9th standard itself. Tangent. Tangents are the lines drawn to a circle touching only one point in a circle. If it is a circle, if you are drawing a line and if it touches only one point, a single point in the circle, it is said to be the tangent drawn to the circle at that point. Tangent of the circle at that point. See, every body in a circular motion does love to follow the tangent, does like to follow the tangent. They wish to go according to their tangent. But what happens? Pull from the center, make its motion along this way. This is the actual motion. This is the motion they wish to go. That is according to the tangent. So it gets a circular motion. See, if the radius is r, how can we find the speed? What is the equation of speed? Speed is equal to distance by time, isn't it? Speed equal to distance by time. Distance by time. See, so if a body starts its motion from here and reaches back to here, what is the distance traveled by the body? As it is a circle, the distance traveled is the perimeter or circumference of the circle. As it is a circle, we are considering instead of perimeter, we will be telling circumference. So circumference of a circle is equal to 2 pi r. So this is 2 pi r and time is denoted by the letter t. So in the case of a uniform circular motion, the speed of the body v is equal to 2 pi r by t. This is the required equation. So that's all about